All right, so this is just old-fashioned addition. 5 plus 5, boom, 10. Yeah, I mean, you could stack these if you wanted to. And then 6 plus 4, oh, 10 right there. It's pretty good. And then 7 plus 3, 10. Now, in some cases, when we see some old-fashioned basic addition right there. Now, one thing I want you guys to notice on this one is the answer is 10. And that's pretty important there, okay, because we find a pattern. See how the first number, it went up by 1, but the second number went down by 1 each time? That's some good old-fashioned arithmetic right there. If you can see those types of patterns in mathematics, then at least at this beginning point, then you should be able to notice a lot of the patterns that we will see. Now, something you'll understand about mathematics is it's very exact, although there's curriculums that are changing that. But for now, math is pretty exact, okay? So we don't usually want estimations, right? Like 15 plus 7 is 30 because we estimated or something like that, okay? It's garbage. What we want you to do is find exact estimations. Now, calculations, all calculations and values should be exact as well. And for now, in this unit, we are not using calculators. Okay, so even if you have your own calculator, that's fine. It's just we're not going to be using them in this unit. So in the long run, it is usually better to memorize some of those values. And this goes back to, again, some basic arithmetic. Maybe you did this back in, I don't know, 3rd or 4th grade. Memorized all of the very first addition, subtraction, multiplication, and division facts, right? Like if I say 5 plus 4, if you have that memorized, then it comes pretty quick. Now, does it mean you have to have these memorized? No, it does not. It just means that it may take you a little bit longer to do the work, which is fine. But the sooner you get these memorized, the faster you'll be able to do these operations, and the better you'll be able to understand the new concepts when we encounter them, all right? Something you'll want to understand about math and numbers is that they represent usually like bigger things, right? Like, and this goes way back to ancient times, whether it's Egypt or Greece or any of those other ancient civilizations. But numbers represent, well, some kind of value, but it's symbolic for us. I mean, maybe there was a culture one time that represented 1 with 1 dot, right? Or 2 with 2 dots, something like this. But the problem with that is once you get to like numbers over 10, then yeah, we consider those compound values because we're combining digits together. Now, the beauty of the system that we work with is that we look at place values, okay? Instead of just like old-fashioned Roman numerals, right? If you did 5 and then added 5 right here like this, you'd be like, dude, how does that equal this? Okay, but with the place value system that we have, it works out very nicely. So the numbers and digits, they're just symbolic hieroglyphs, if you will. Just so we understand, when we see mathematics written out, it really is symbolic representation of what you could consider sentences. It's just a lot easier, a lot faster to use the symbolic representations we have for mathematics. And that's pretty nice. So here's our objective. I can add with negatives and positives by place values, right? So what you see on the worksheet that you have is that towards the top, right under where it says name, date, period, it says objective. You're going to take 1 minute. You're going to write this objective down. And the reason for that is so that it can kind of stay in our minds as we look at the material we're going to be going over. You'll have something to refer to and think, oh, what is it I'm trying to do here? That's what the objective tells us. All right, so take 1 minute, copy this down. Now, you'll see on the classwork worksheet that it says adding integers. Integers include negative values. So, but we're not looking at decimals or fractions yet. We should only be looking at whole values, okay, that are negative sometimes. Of course, we'll still be dealing with some positives, and, well, that should be okay, hopefully. So, like I was saying before, at least the first 10 addition values, right, from 0 to 9, you should be able to add all those numbers together. So if I said 8 plus 7, you should know pretty quick that that's 15. Now, could you use a chart like this? Yes, you could. And remember, in this unit, we're not using calculators. But, and that's why it's important to see, again, the patterns here, right? So, see, like, if I add zeros here, if I add 0 to each of these, but I increase these values by 1, the sum increases by 1 as well. Now, I just used the word sum. Sum is the answer to an addition problem. That's important for you to know as well. But we need to go all the way up to 9 plus 9. Why not tens? Because when we operate by place value, we're only working with 1 digit at a time. So we'll never see anything bigger than 9 plus 9 when we add by place values. So I would say if you don't have these memorized, I'd put them somewhere that you may be often enough to see it, so that you can look at these math facts and memorize them. I know in the past some students have said I put it next to the John and that helps me memorize them. I don't get it, but whatever. Same with subtraction facts, because we got to be able to do some subtraction. Notice that these do not go into the negatives. That's on purpose. We're not going to be going in, like, we shouldn't see negative values here. Or we shouldn't see more subtraction than what we have, okay? So as long as you can do up to 9, I guess 9 minus 9 or 1 minus 1, then you should be good. But you should be able to do all of these. If you can do all of these, then the rest of the math takes care of itself. It happens pretty quick. It's just we can add a couple extra rules as we go, all right? Now, place values. We won't see any decimals right now, but just so you understand, there is a decimal place right there on the right. Okay, but you'll see every 3 digits is a new place value. We can call those periods if you'd like, but it's up to you. But notice it's always ones, tens, hundreds, ones, tens, hundreds, ones, tens, hundreds. And then we just change the label for each period, right? So first is the base units, ones, tens, and hundreds. And then it's 1,000s, 10,000s, 100,000s. Or the next one, millions, 1 millions, 10 millions, 100 millions, and then billions and trillions, okay? I don't know that we'll see any numbers in the trillions, but I suppose we could. The place value system is what makes our number system, and the way that we work with numbers mathematically, it makes it so unique. Like I was saying before, right, if you go back to Roman numerals and you take a 5 and add a 5, I mean, you could say you got a 5 and a 5, but it comes out as 10 like this. It's like V and V is X. What the crap is that? Well, that's the way it used to be, I suppose. And, or you know, you'd have to count dots, right? Like, hey, like on a dice, 3 plus 4. Okay, now you actually have to count. You'd have to count all the dots in order to know that this would be 7 right there. I mean, how do you represent 7 with dots? 1, 2, 3, 4, 5, 6, 7, something like that. Yeah, garbage, right? But the way that we do things, we're just dealing with individual digits. This would be represented as 3 plus 4, boom, 7. There you go. But that goes back to the addition facts. If you can have those memorized, then there's a lot of math that you'll be able to do. So here we go, find the sum. And remember, sum is when we're adding, because that's our objective today specifically is adding, but we'll do some subtraction, you'll see. We're going to add these two values together, 187 plus 924. Now, we're going to stack and add these by place value. So for 187, I got a 1 in the hundreds place value, an 8 in the tens place value, and a 7 in the ones place value. I am going to be adding these, so I'll show the operation with addition here. Then I got the second value. I got a 9 in the hundreds, a 2 in the tens, and then a 4 in the ones place value. I listed these from the bigger place value down into the ones. Could you start in the ones and list them to the hundreds? Yes, you could. It's up to you. But I'm going to add these by place values. I always start on the right, as far to the right as I can go. In this case, we should only be dealing with the ones place value. So now I say, okay, 7 plus 4. And if you don't have those math facts memorized, it's okay. It is okay to use fingers, right? So I'd put 7 fingers up, and then I bring 4 more fingers up because I'm adding, right? So 1, 2, 3, 4. Now I went into 10, and then the fourth one, I have 1 more finger up, but that makes 11. So I did 7 plus 4, and I'm putting the addition sign here because I am only focused on the ones place value. 7 plus 4, boom, I got 11. Okay, now some of you know what to do at this point. You'd say, well, the 1 that's over here in the tens place value, I'm going to bring it up here. That's called carrying values, and that's okay to do that. So I wouldn't want to show the 1 right here. I'd show it up here because it's a 10. It's a full 10. So I'm going to include it in the tens place value. So now in the tens place value, I got 1 plus 8. So, I mean, you could put 1 finger up, 8 more, that's 9. And then tack on another 2 fingers, boom, that'd be 9, 10, 11. That's 11. Now, again, I could show the 11 like this. But since this one here on the left is in the hundreds place value, I'm just going to tack it onto the hundreds place values up here at the top. That's there's a 1 right there. That's carried over. Well, then I got 1, the 1 that I carried, plus this one. That'd be 2. That's 200. And then this other 9, that's 200 plus another 902. 3, 4, 5, 6, 7, 8, 9, 10, 11. There we go, 11. So I end up with another 11 right there. And that's all the place values that I had to work with, right? I worked my way all the way up to the hundreds, and I end up with 1,111. Some people like to show a comma in between the periods, and that's fine if you do. I don't think you're going to want to do that on the homework, though. Just be careful about that. Well, Mr. Sal, I thought you said we're going to work with negatives. We will. We'll talk about negatives. We'll get there. All right, what about 17 plus 13? A little bit smaller numbers, but it's still doable. And I still going to stack these. I'm going to stack these because we're not using calculators, right? I got 17, so 7 in the ones, 1 in the tens. And then when I add this 3 here, this 3 right here, it's only in the ones place value. So be careful. You need to line up your place values. This 3 is not, that's not 3 tens. Don't put it right here, no matter how sloppy your work is, because then you start to mix these up with, what's that? 1 plus 3 is 4, you get 47. That's garbage. That's not what the answer is. So I'm going to add these, starting in the ones place value. Always start in the ones. 7 plus 3, so 7, 3 more fingers, that's 10. Now again, I could show 10 like this, but I'm going to carry that 1 over into the tens place value because there's other 10s. 1 plus 1, boom, that's 2. So my final answer here, 20. Hey, here's a tough one. 1 plus 1. Now, like I said, there are curriculums out there that are like, there is no right or wrong answer. But for now, there is. Okay, so we're going to say 1 plus 1. And look, I'm pointing this out because some students are like, dude, I still got to use my fingers. Don't feel stupid if you got to use your fingers. Okay, I got 1 finger up, another finger up, that's 2 fingers, right? Some people are like, dude, I feel stupid. Please don't. Math is not a good indicator of intelligence. So 1 plus 1 is 2. There it is. Now think about this too. If you go back far enough in history, right? You got Roman numerals 1. You got 1 plus 1, and then you'd end up with 2, something like this. And that kind of makes sense, right? Or even dots, right? 1 plus 1, that's 2. That's okay with smaller values, but if you go back to problems with that 900 and whatever, and start looking at those, yeah, it becomes a lot more difficult to start adding those types of values. So our place value system is very nice. Even with small values, it works out very nice. All right, now we have some subtraction, okay? But we do subtract by place value as well. Well, you'll notice on this one, let's set this up, because I'm going to stack and subtract these. So I got 942, and I am purposely giving myself a little space between the numbers so that I can work in between each place value. And then I'm going to subtract from that 718. Now, I didn't specify this before, but for subtraction, which we are doing now, the order of the numbers does matter. Okay, with addition, even though the 718 is second, you could have switched the stacking for addition. But you cannot do that with subtraction, okay? With subtraction, the first number here, the 942, whatever it is, it always has to be above the second number when you're stacking for subtraction, okay? Now, starting in the ones place value, which is what we should always do, I got 2 minus 8, right? So 2 minus 8, once again, we can technically ignore the rest of this stuff for now. Just focus on 2 minus 8. But the problem here is that I'm taking away too much from the 2, right? It's like saying you got $2, you spend $8, you didn't have $8 to spend, okay? So that means that I gotta increase the value of that 2. Well, how am I going to do that? Well, now I do need to see some of these other values. I'm just going to go to the next place value and see how this becomes 42 minus 18. That's doable. That's doable. But what I'm going to do is, because I'm still looking to just increase the 2 from the ones place value, I'm going to take a 10 out of the 4 and then tack it onto the 2, which makes it 12. See that right there? Now, I took that away from the 4, right? So usually they'll show by crossing that 4 out and then showing a 3 there instead. Well, does that mean I changed the value of the 4? No, it doesn't. It just means that I split it up. You can do that? Yes, you can. In mathematics, you'll find that you can manipulate all kinds of things without actually changing the values. You can always change the way things look as long as you don't change the value. So that's what I just did right there. I got a 4. Is it still 4? Yeah, 3 and 1 is 4. See that? I just split it up. I wanted one of those 10s in the ones place value. So now, and I guess I'll cover that up again. Now I got 12 minus 8, right? Okay, now I can take 8 away from 12. I do have enough. So 12 minus 8, you can put 2 fingers up and then take 8 fingers down, however you're going to do it. 12 minus 8, if you haven't memorized that, I mean, I'd say that's the best option, but 12 minus 8 is 4. okay? But again, even if you don't have that memorized, you can always just use fingers, 2 fingers up, 8 fingers down, boom, you'll end up with 4 fingers up. Okay? Now that's the ones place value. Remember, we got other values here. In the tens place value, I got 3 minus 1. Remember, it's not 4 minus 1 anymore. It's 3 minus 1. And that would be 3 take away 1, that's 2. Now into the hundredths place value, 9 minus 7. 9 minus 7, 9 fingers up, 7 fingers down, that's 2. Now I put each of the place values in this one in as a different color. That's because I want you to understand that we're focusing on each place value separately. We work one place value at a time. This is our final answer though, 224. All right, 31 minus 7, some smaller numbers. I think it's doable though. I'm going to set this up, stacking. I got 3 in the tens, 1 in the ones. And then I'm going to take away, so let's just take away or minus this 7 right here, right? And that's just in the ones place value. So 31 minus 7. Once again, the 1, take away the 7 is too small. I can't take away 7 from 1. I got to increase this value. So I'm going to take this 3. I'm going to take one of the 10s away from it and make this 11. But if I do that, I took 1 away from the 3. So now it's only 2 in the tens place value. Now we got 11 minus 7. 11, take away 7, that's 4. And then the 2, that just drops down. So it's a 24 right there. So for addition, we carry values over. For subtraction, we borrow values in order to increase some of the values there. All right, adding integers. Now, integers, right, are negatives. We were only dealing with positives right there on those last couple of problems, but it's possible to have negatives involved. Okay, so negatives are going to zero out positives. So for example, at least when they're the same, right? So if let's say I had 7 positives, and then I also consider with negative 7 right here like this. What happens is these 7 positives are zeroed out by these 7 negatives, meaning their combined value ends up being 0 like this. And we can use tiles to demonstrate this, which hopefully will kind of demonstrate the point, okay? Notice this is kind of the same statement. We just switched where the negatives and positives were. That's important to know because negatives will zero out positives, but simultaneously positives zero out the negatives. It's the same thing. So this one, I'm going to use tiles on this one, and hopefully that kind of demonstrates what the crap is going on, right? So I got negative 2. So I'm going to start with this negative 2. So I'm going to take these negative tiles right here. Got 1, and then another one, right? There's 1, 2, like this. And then we're going to add 4. Now these four are positive, right? So I need 4 of these positive tiles like this, which we can do. Okay, so there's 4 positives, right? Now remember though that the negatives are going to zero out the positives. So what I'm going to do, I'm going to take these and separate them again. So there's my 2 negatives there. If I took this positive and this positive, the total value of these 2, that's a 0 right there, and that's a 0 right there. Okay, now the nice thing about zeros is that we can ignore them, just like we do when people are zeros. But in any case, not that you should, but in any case, this is going to zero out these 2 negatives are going to zero out these 2 positives, 2 of the positives. So when I add these 2 together, what do I get? Well, all I was left with was these 2 positives, so the final answer here, positive 2. Okay, now I'm using tiles right now. There's a time when that becomes a little impractical, but we'll see. What about this one? Negative 1 plus 2. Okay, well, I'm going to start with my negative 1, so it's negative, and I'll take my negative tile right here. There's my negative 1, and then I got 2 positives. So I'm going to take 2 of these positive tiles. There's 1 and 2 right here. And can I combine any of these to make 0 pairs? Yeah, there's 1 and there's 1. So that's a 0 pair right there. Okay, so when I add these together, what I get is just whatever was left over. Boom, it's this one right here, that positive, that's just positive 1. All right? Now, why am I showing this to you? Because I'm never going to force you guys to use modeling like this with tiles. But hopefully it helps you to it demonstrates an understanding of what's happening with positives and negatives when you start to combine them with addition. Because as it turns out, even though we're looking at addition of integers, when we start looking at subtraction of integers, we're going to be changing it into addition anyways. So adding opposites, this is what we're going to do. The first thing you're going to do when you add opposites, that's with negatives, right? positive is opposite to a negative. What you're going to do is you want to figure out the sign of the answer first. Okay, and you'll do that by looking at the two numbers that you're going to be adding. And the number that's bigger, that will tell you the sign of the answer. Okay? And then what you're going to do, if they're opposite signs, you take the big number and subtract the small number. That's what it's showing right here. You take the big number, subtract the small number. That's the sign. That's the sum. But you've already figured out the sign of that sum. So whatever sign you found, that's where you're gonna tack onto that sum. But remember, you want to figure out the sign of the answer first. Okay. Now again, we're doing addition because if you can do addition, you can do subtraction with just one extra rule. That's it. Because with subtraction of negatives, we'll always change it. We will always change it in this class to addition. All right, like this one. Okay, that's negative 82 plus 12. Okay, so on this one, remember the first thing I want to do is figure out the sign of my answer first, the sign. Well, how do I figure out the sign? These are opposite signs, right? That's a negative 82 and a positive 12. They're opposite signs, okay? So that means I want to find the sign of the bigger value. 82 is bigger than 12, and it's negative. So I know, and I'm going to put this in right now, that my answer will be negative. Now that I know my answer is negative, I just take the big number, which is 82, and I now subtract the smaller number, which is 12. Okay, so I'm going to subtract these by place value. In the ones place value, 2 minus 2 is 0. In the tens place value, 8 minus 1 is 70. Now, the answer is not 70, though, right? Remember, we got to tack on the sign of the answer, which was negative. It's not that it's 70, it's negative 70, because we knew the sign of the answer first. So that would be my answer right here. Usually the question comes up at this point, well, why did we subtract? It's because these 12 positives zeroed out 12 of those negatives, and zeroing out means they kind of zeroed away. So they took those away from each other. So they took these 82 negatives, the 12 positives took away those, at least 12 of those negatives, and we ended up with 70 negatives in the end, okay? All right, what about negative 3 plus 6? Okay, same idea though. The first thing we would want to do on this is to figure out the sign of the answer. And these two are opposite signs. One's negative, one's positive. That's okay. It's just now the positive is bigger, which means the answer will also be positive. Okay, now we do this because the signs are opposite. When they're the same signs, we'll look at those examples too. But for now, they're opposites. Since they're opposites, I'm going to take the big number, which is 6, and I'm going to subtract the small number, which is 3. And whatever I get from this difference, that will be the final sum with the positive sign. So 6 minus 3 is 3, so I know my answer is positive 3. When you put this into Canvas, make sure you don't need to put the positive sign there. It's just 3, because we don't need to show positive signs. These are smaller numbers, but it's still doable. You should be able to do them no matter how big or small the values are. That's because the process really never changes. So here's another one, 30 plus negative 64. Take 1 minute and try this one out. Okay, then we'll go over it together as a class. 1 minute, go. So for this one, the answer you should have gotten is negative 34. Okay, now how do we get that? That's the question, right? So here's how we get it. Is I see that the two signs are opposites. One's positive, one's negative. The negative value is bigger though, so I know my answer is going to be negative. That's how we know the answer is negative. Well, how do we get 34? Because it's addition, right? Well, it is addition, but the signs are opposites. So we're going to take the big number, which is 64, and then we're going to subtract the small number, which is 30. So whatever I get from this, that would be the number, the numerical value of the answer, but the sign remains. So 4 minus 0, that's 4. In the ones place value, in the tens place value, 6 minus 3 is 3. So see how we get the 34 there as well. Now we know why the answer was negative and why it was 34 as well. So negative 34 is our final answer. Done. So next up, we're adding with the same sign. Now we've done this already today, right? Whatever the values were, maybe like 7 plus 3. Okay. Whenever you add values of the sign remains the same. So like with positives, you know your answer is going to be positive, right? The same is true with negatives though. So the values If the values have the same sign, the answer will have the same sign. But then you will always add the values no matter if they're positive or negative, just attaching the sign to it at the end. Okay, so once again, the process is find the value, the sign of the final value, and then operate. In this case, when the signs are the same, we are going to add the values. Here we go. Find this sum. Okay, it's -9 plus -2. Do we have to put the -2 in parentheses? Yes, we do, so it doesn't look like plus minus. Now I know, just by reading this, -9 plus -2. Remember the hieroglyphics theme? Mathematics is just symbols of words. So -9 plus -2, that's how that reads. But what I notice about these two values that I am adding is that they are both negative, which means my answer will also be a negative. Since the signs are the same, negatives, I'm going to take the two values, 9 and 2, and add them. 9 plus 2 is 11. No need to carry because we don't have any values in the tens. It's just don't forget to tack on that sign. It's now -11. -41 plus -72. Okay. See here, the signs are the same, negative and negative, which means that the answer will also be negative. Now I'm showing that negative out there again, so I don't have to forget, hopefully I don't forget to tack it onto the answer. Since the signs were the same, we're going to take the two values, 41 and 72, and we're going to add them together. So in the ones place value, 1 plus 2 is 3. And then in the tens place value, 4 plus 7 is 11. Again, I don't need to carry this one over because there's no values in the hundreds to carry it over with. So it's just going to write out as 11. 11 and 3, that's 113. Just don't forget to tack on that sign. It's -113. That would be my final sum right there. What about adding problems with many terms? Just add two values at a time. Focus on two at a time, especially when we're not using calculators right now. Could calculators do all of it at a time? Yes, of course, but we're not using calculators right now, okay? So you got to remember the rules, though. If they're the opposite signs, you got to figure out which one's bigger and then subtract. If they're the same signs, figure out the sign of the answer of the two and then add the two values, right? And yeah, you can use the commutative and associative properties of addition, but I'm not going to, and I hope you don't either, but you can, you could. All right, here we go. Lots of addition. -84 plus -5 plus 17 plus -61 plus 43. And it's nice to use math symbols because that's like a giant paragraph just right there if you were to write that out in words. So, once again, let's make this a little bigger. But you only focus on two values at a time. So, also, not only do you focus on two values at a time, always start from left to right. That's my recommendation. There's a purpose for that. But for now, I'm just going to focus on this -84 plus 5. That's it. Okay, and once I get that, once I get -84 plus -5, then I will consider the rest of the three values that are in the problem. But I'm going to take these two and reduce them into one value. Okay, so I'm going to simplify this. I'm going to make it smaller. What do I notice about this? Well, the 84 and the 5 are both negative. It's the same sign, so when I combine these together, it's going to be a negative value, right? Then I'm going to take the two values, 84 and 5, and add them together. 4 plus 5 is 9. Drop the 8 from the tens place value. We end up with -89. So, combining these, I get -89. Now, I can tack on the rest of this problem, right? So I still got the plus 17, plus -61, plus 43. But now, once again, I'm going to focus on two at a time. So here's the two. The next two, from left to right, -89 plus 17. Maybe I should have given myself more space. -89 plus 17. Let's do this one. The 89 is negative and the 17 is positive. They're opposite signs. So when I combine these, which I will, -89 plus 17. The 89 is bigger and it's negative, so I know my answer is negative. That's okay. But then I'm going to take the two values, 89, the bigger one, and subtract the smaller one, 17. 9 minus 7 is 2. In the ones place value, 8 minus 1 is 7. That's 72. But -72, right? Because it was negative. So now I got -72. Tacked on with the rest of these values. There's only two more. So that's plus -61 plus 43. Okay, and then I'm going to focus then. In fact, you know what? I'm going to move this over so I have more space to work with. And move it over here. Okay. Now the next two, negative 71 and negative 60, negative 72 and negative 61, adding together. These two values are both negative, so I can combine them. The answer is going to be negative though, because they both have negative signs. Since they have the same sign, I'm going to take the two values, 72 and 61, and I'm going to add them together. Just I know my answer is going to be negative. So 2 plus 1 is 3. 7 plus 6, that's 13. So I end up with negative 133. I can still add that 43 though. It's just now the signs are opposite, right? Negative 133 and positive 43. Let's go ahead and combine these. The answer will be a negative, because the negative 133 is bigger. Well, since they're opposite signs, take the big value, 133, and subtract the small one, 43. In the ones place value, 3 minus 3 is 0. In the tens place value, you got 3 minus 4 there, so you're going to have to borrow this one. Make it 13 minus 4. 13 minus 4, 3 fingers up, 4 fingers down, that's 9. So we end up with negative 90. Is there any more values to work with? No, there is not, which means we're done. So we should always end up with one final value when we're operating like this, at least for now. There is our objective for today. I can add with integers, well, negatives and positive values, right? So we should be able to add, just add for now with negatives and positives, right?